So we've been looking at how we can approximate the area under a curve using rectangles, right? At first, we stuck the top right vertice of a rectangle up against the graph, and then we stuck the top left vertice of a rectangle up against the graph, found their areas, added them together, and then said, okay, this gives us a nice approximate of the area under the curve. Now we're going to do something similar, but a little bit different. Where instead of hitting the graph at a vertex of a rectangle, we're going to hit the middle of the rectangle, hence the midpoint Riemann sum. So we're going to stick with our function y equals x squared, the one that we've been doing. And we've been evaluating y equals x squared. We've been finding the area under an interval from either 0 to 3 or -3 to 0. This time I'm going to extend the graph a little farther so we have more room to work with. So let me just draw this for us, right? Those are pretty nice lines. All right, so we got our x-axis and our y-axis. And instead of going to 3, we're going to go to 6. So let's say we got 1, 2, 3, 4, 5, and 6. Okay. And 0 right here, this is our origin. So we've got our graph of y equals x squared, not drawn to scale. This is not perfect, but it'll do. And we want to find the area under the curve. Now, like I said, we are going to be using the midpoint of a rectangle, right? And I want to do this with 3 even subdivisions like we've been doing, right? So we want 3 even subdivisions. We're going from 0 to 6, meaning that the length of each, or the width of each of our rectangles should be 2 units long, right? So if each one is 2 units long, then all of our midpoints would be at x equals 1, 3, and 5. Now, if that doesn't make sense, let me draw the rectangles and show you what I mean. So we want 3 midpoint Riemann sum approximations of even length, and this is how we're going to do it. So they're all length 2, right? So our first one, the midpoint of the rectangle hits the graph, right? We draw to the right a little bit, we draw a rectangle, and then to the left a bit, right? So there we go, that's 1. Our next one's going to be at x equals 3. So the middle of the rectangle hits the graph, and then we draw a rectangle like this, right? And for our last one, it's going to be at x equals 5, so that's about right here. Draw to the right a little bit, draw down, draw to the left a little bit, and draw down. Now, does this make sense? We wanted 3 even subdivisions doing the midpoint, right? Our total length that we're evaluating is from 0 to 6, so we had 3 subdivisions that were all length 2. So we've got our rectangles drawn, and as you could see, let me change up the color a little bit. As you could see, it gives us, we're underestimating right here, but we're overestimating right here. Underestimating right here, overestimating here, underestimating here, overestimating here. So that's why the midpoint Riemann sum can be a good choice to do when trying to approximate this area under a curve, because it kind of cancels out that issue of over approximating and under approximating that we had when we were doing left and right Riemann sums. Now, these are not going to perfectly cancel each other out, hence why this is still an approximation and not an exact answer. But you can see why this might be a viable option for approximating the area under a curve. So now that we've got our rectangles drawn out, right, we all know that they're all length 2, right? This is all going to be length 2, length 2, length 2. We just need to figure out what each one of their heights are going to be, right? But we know how to do that. We just need the y value at that x value. So our x values are 1, 3, and 5. We'll plug that into our equation for y equals x squared and solve for y, right? So we have y at 1 is going to be equal to 1. Y at 3, so remember, we're just doing y equals x squared. This is equal to 9. And then y at 5. 5 squared is equal to 25. So these are the areas of all our rectangles, right? This one is rectangle 1, this is rectangle 2, this is rectangle 3. Now, like we've done with all the other Riemann sums, we're going to combine our areas of our rectangles and get an approximation for the area under the curve. So we are just going to do 1 plus 9 plus 25. Simplify that, that gets down to 10 plus 25, and we get a rough approximation of our area equal to 35 square units. So that is how you do a midpoint Riemann sum. If you made it to the end of this video, thank you for watching. I really appreciate it, and I hope you learned something.